let's go into Canvas. And under Canvas, let me show you that this is spring 2021, Chem 201. That's this right here. We'll go into the module page. Oh, by the way, I hope you guys saw the announcement. Some of you qualify, so please take a look at some research you can do. If you're going into medicine or graduate school, this will really look great in your resume. And if you want, I can always write you a letter of recommendation. I do that a lot for my analytical chemistry class. And again, it's good opportunity to get more exposure. Okay, so let's go into the module. And under module, this is what you will see. Let me take this out, and let me blow this up so that you guys can see this completely. So we're going to go to activity 3, which is, by the way, the Zoom sessions are here. Look for the one that says spring 2021 spring. Okay, and as soon as we're done today and Zoom emails me, I'll go ahead and process it and update the video for today's discussion. But for today, this is actually the wrong class because this is the 201 lecture. This is the lab. Okay, so let's go take a look at activity number 3. This is the Zoom session from last semester. This is the information, but I want to look at activity 3, and I'm going to do a preview on this so you guys can see the actual worksheet that you guys are going to complete for this activity. Okay, so let me see. Pull this out of the way. This is what you guys will see. This is question 1. It gives you some concentrations or percent volume right here and the signal. So this could easily be the concentration of chemical and absorbance or some measurements from an instrument. And what you are going to be doing is you're going to be plotting this, and then you're going to get the slope, the intercept. The S sub M is the standard deviation of the slope. S sub B is the standard deviation of the intercept. S sub Y is the standard deviation of the Y value, and R squared is the correlation factor. R squared tells you how well your data points fit a straight line because we are doing linear regression. Okay, if the correlation factor is 1.0, then your points is directly on top of a straight line. If it deviates slightly, then you will get a value like 0.99 something. Usually, among scientists, we quote correlation factors of the numbers of nines. So if we say, yeah, my correlation factor is up to 3 nines, and then some digits after that, that really is good. If your correlation factor is only 1 9, that's okay, but it could be better. If it's got no 9, then the correlation factor is really bad. Okay, so you will see that when I do this example for you. Okay, if you have Excel in your computer, you could probably multitask because you could see the Zoom video or the Zoom session and then open up Excel as well. Okay, so I'm gonna bring Excel to the desktop so that you guys can see what's going on. And I will try and go slow so that you can see my cursor, so you can see what's going on. So what I did on this table was I simply put CH4, that's that, and signal, that's that, and then I put in the values. 0, 0.062, 0.122, 0.245, 0.486, 0.971, 1.921, and then the signal 9.1, 97.5, 95.6. So if you have Excel, why don't you guys go ahead and do that now so that you can do this problem same time that I'm doing it. Okay, so let me go ahead and just get a blank slate. I'm going to increase the size of that. I'm going to put CH4 right here. And I'm going to put signal right here. And then I'm just going to put in the value 0.062, 1.122, and let me move this out of the way so that I can see the rest of these numbers. Again, I'm going slow so that you guys can actually follow along. And this is what we would normally do if we were meeting face to face. Everyone would be punching in these values, because if you don't do it, then you're going to forget. So these are my first initial values. Okay, those are my initial values for CH4. Plug in my other computer. Now let me put in my signals. My signal is 9.1. The first problem, or the first thing that you need to do after you put this all in an Excel spreadsheet, is to zero or normalize the signal. That is, when you have 0 CH4 and your signal is 9.1, then that's an offset that you need to correct for. And let me show you how that's done. For those of you who have Excel, feel free to work ahead, or who already know Excel, feel free to work ahead. But most of you probably have not been exposed to Excel. Like I said, if you're going to go into science, Excel is the software scientists generally use. Okay. So the first thing that it says it right here says, subtract the blank value from all values, then use Linest. So I'm going to do the corrected signal. And that just means that I'm going to subtract 9.1 from this value. So when I have 0 methane, the signal should be 0. So how do I do that? I write an equation. Now notice this equation bar right here, because that's what I'm typing in. I just put equals. When you have an equal sign, it tells the cell that it's ready for an equation. If there are no equal sign, then it just treats it as a number or a text. But when you have an equal sign, then it's ready for a formula. So what I'm going to do is I'm going to say it equals, I'm going to click here, and notice how it gets filled with B3. That's because that cell is B3. See how it's like Battleship, B3. And then I'm going to subtract. I'm going to put subtract, and then I'm going to click on this cell, C3. Okay. So what should happen is that, sorry, it's C3 minus C3, because we want that first signal to be 0. So I'm going to click on C3 minus C3, and if I hit return, that equals 0. Okay, so with 0 methane, the correct signal should also have a 0 voltage detected. Now, if I click on this cell, I just move my mouse and click on there, and then you see how there's this dot or this square right on the right corner. Okay, let me see if I can't blow this up for you guys, because I really want you guys to see what I'm doing. Oops. This right here, if I put my cursor right here and then hold my mouse button down and then drag it, okay, while my mouse button is down, then I have something called the propagation of calculation. What exactly is a propagation of calculation? Propagation of calculation means that I'm going to take this equation right here, C3 minus C3, and then I'm going to propagate the calculations all the way down to where I drag it. Now, if I click over here, what you see is that it's C4 minus C4. Here, it's C5 minus C5. Here, it's C6 minus C6. And that's why I get 0. But that's not the correct equation that I want. And the reason why it's not the correct equation that I want is because then it's just the signal is just subtracting itself. What I need to do is I need to take this value and subtract this 9.1 value. By the way, this is in error. That should be 47.5. Make sure you type that correctly. Okay, so the way I'm going to do that is I'm going to tell Canva or Excel that this second C3, okay, has got to stay on C3 because I want all those numbers to subtract 9.1. And so the way I make sure that it's stationary is I put a $sign. Okay. Yeah. Let me go ahead and do this. Okay. I'm going to type equals, and then I'm just going to click on C3, and then I'm going to type in minus, and then I'm going to click on C3 again. I'm just clicking on those cells. And as I click on those cells, the equation fills in. Let's say I click on this. See how it changes? Well, I want it there. And then I hit return. Okay, that's what I'm doing. And then the propagation of calculation, I just click on this cell, go to this right corner right here, hold down your mouse button, and then drag it all the way down. And that's how I get a propagation of calculation. But right now it's not correct. What I need to do is I need to make sure that I take 47.5 and subtract 9.1. I get 95.6 and subtract 9.1. I get 193.8 and subtract 99.1. And how do I do that? I make sure, I go back to that equation, and I make sure that I fix the second C3 to its position. And the way I do that is I put a $sign. If I put a $sign before the C, then as I drag it across, it'll be stationary. If I put a $sign after the 3C, then as I drag it down, it'll be stationary. So this is the equation I want. C3 minus C $3. Okay, or you can just type it in. I'm going to hit return, and then look what happens when I do a propagation of calculation again. Again, propagation of calculation means that you click on that cell, go to the right corner, press your mouse button down, and then drag it. Okay, now let's click on one of these cells. The formula for that is C4, which is that minus 9.1. Because we now told the formula that your second variable is now fixed at C3 through the series of calculation. Let's take a look at this one. It says this is C7. This is C7 right here. This 387.5 is C7, and I'm subtracting 9.1. Okay, so that's how you do a propagation of calculation, and that's just a simple function technique. So these are the corrected signals now. Okay, these are the corrected signals. This right here, I'm going to highlight in yellow just so that you guys can see. And this right here are my x-axis. So this is my x value. This is my y value. Okay, this is my independent variable. This is my dependent variable. Just so that
Professor?
Yes.
You did the formula equals C3 minus C3 $sign to get that?
No, I did C3 minus C $3.
Oh, okay.
You put the $sign either before the C right here or after the C. If you're going to do a propagation of calculation down, then you do it after the C. If you're doing a propagation of calculation across, like if I had this and I want to do a propagation of calculation across, then I would just do this. Okay. And then in order for it to be stationary at that value as I go across, the dollar sign has got to be before the C. I can do both actually. So I cover both my bets. And so whether I go across or down, it'll always be stationary. It doesn't change. It doesn't change the calculation.
Okay, thank you.
Okay. Yes, please ask questions because I imagine this is going to be difficult when you guys are doing it. Okay. I also have a tutorial that I will release so that you guys can do this, but at least here you can ask me questions in real time. Now we're going to do a graph. And the way we do the graph is you need to select the Y and the X. And the way you do that is first highlight your Y. Okay. And then if you try and highlight your X, what happens is that your Y disappears. So you gotta press, I believe it's Shift. No, it's not Shift because Shift will take that whole array. If you take Y, and I think if you do Option in your keyboard, it's not even Option, I forget. You do Y and is it Command? Yeah, it's Command. So here's what you do. First, highlight your Y values, then press the command in your keyboard, and then highlight your X values. Those are the two columns that you guys are going to be graphing. You always do your Y before your X. Highlight your Y before your X. Otherwise, it's going to flip the axis on you. Okay. Then you go up to, I believe, if you go up to, you should have, oops, sorry. Up here, there's two toolbars. There's one toolbar is directly on your spreadsheet, and there's another toolbar all the way at the top of your menu. Okay, so what I'm going to do is I'm not going to go to this toolbar right here. Okay, although you probably could find it. I'm going to go to the toolbar over here where I'm going to insert. And I'm going to insert a chart. So take a look at that. Like I said, there's two toolbars, one right here in your spreadsheet, and then there's another one right here in your windows for your computer. What I'm going to do, the Y and the X are still highlighted, but I'm going to insert, and I'm going to insert a chart, and the chart is going to be a scattered. It's got to be scattered. Oops, I did that prematurely. So it's a chart, scattered XY. Okay. I believe there is also a there might be a, yeah, here under insert, if you go to the spreadsheet, again, let me highlight this. You can find this. And then if we go to insert and we can do, I believe it's this one right here, this little icon. Now it depends on the version of Excel that you have, but you should be able to find a menu where you can insert a chart. And what we want is a scattered. That's what you want. So I'm just going to click on scattered. I'm going to do this, not scattered with lines, but with just dots. And there's our graph. Okay. So you guys should have this right here. And it's basically just plotting your X value. Notice that my X value here is Mia. You can always take these handles and make it smaller so it fits. You notice that your X value is 0.51, maximum's about 2, and that's because your X value goes from 0 to about 1.9. Your Y value goes from 0 to about 1800, and that's because your values here goes from 0 to 1662. So that's your Y value. If you click on the title, then you can highlight it and just put a title in there. You can say CH4 versus, in this particular case, I believe it was the millivolt signal in millivolts. So that's how you change the title. Just click on that right there, and then it should highlight. You click on that, and then take your cursor and just highlight it. Okay. You can also click on these right here, and you can change the font, or you can change the partition. Anyway, let me go ahead and move on. If you click on any one of these dots, I can click here, I can click here, it'll highlight the series. Then I'm going to do for those of you who have a mouse, you can do a control click or right click. It's going to take you to the contextual menu. So if you left click, or you do if you have a Mac, press the control sign or the control in your keyboard and then click one of these. And what you will see is this contextual menu. And what you guys are going to do is you're going to add a trend line. When you add a trend line, it basically gives you this menu right here. And this menu tells you that you're going to fit this to a linear. You're not going to fit it to a log. You're not going to fit it to a polynomial. You're going to fit it to a linear. Again, add trend line. It's going to be linear. And then this is important. You're going to set the equation to be displayed, and you're going to show the correlation factor. You're not going to make this necessary. You could make this go to 0, because notice that your origin has got to be on 0, 0. So that's okay. But for the most part, you don't need to worry about that. Okay. But for this case, you can force it to go through 0, because your data says that for 0 methane, you should get no signal. So by doing that, your equation is simplified. This is the equation of the line that you have. If you don't make it go through 0, let me just show you this again. Then you guys are going to see an intercept. See how there's an intercept right here? Let me erase this. So by not making it go through 0, let me redo this every time so I'm gonna do need to add a trend line. Do this again. I apologize for that. Me plot this. My mouse is playing tricks on me. So again, I'm going to add a trend line. You should get this box right here. Notice that when I set my equation to show my equation, it shows y equals mx plus b. This is your intercept. This is your slope. When I don't force it to 0, it means that this line passes through negative 22.08. But when I force it to 0, set intercept to 0, then that disappears, because it goes through 0 right away. So there is the intercept is 0. I want to show a correlation factor. That's it. So this is what I will take. This is your equation. It basically tells you that the intercept is 0 and that the slope is 852.14. I'm going to change this again, CH4. Okay, so you guys should be able to get this. Now, the next step that I'm going to do is I'm going to show you how to do Linest. Okay, so I'm going to move this out of the way. because I want to show you how to do Linus. Linus is not an easy program to do, but it can be done. So what I'm going to do is I'm just going to make this small, because I can always resize it by pulling on these corners. But I want space down here, and I want this thing big enough so that you guys can see. Okay, so I think you guys can see my whole diagram. I'm gonna highlight a 2x3. It's got to be a 2x3. That's important. Okay, so let me go ahead and highlight that. And then I'm going to label this M. I'm going to label this S sub M. And I'm going to label this R squared. Because these values over here are going to be the slope, the standard deviation of the slope, and the correlation factor. I'm going to make sure it justifies to the right. And then here I'm going to put B, that's the intercept, S sub B, and S sub Y. So I need a 2x3 area by which I put in my Excel spreadsheet. This is important. Next thing I'm going to do is I'm going to highlight this 2x3, and then I'm going to click on my equation bar. You guys should have an equation bar. If you don't see your toolbar, it's called a toolbar, look under view. You should be able to see your toolbar here, formula build toolbar. If it's not displayed, then you need to display it, because you're going to be typing in the equation. So I've got my 2x3 area highlighted, and now I've got my cursor up here, and I'm going to put equals Linest. Okay, and that's a function that is part of Excel. It'll actually show you that, and then I'm going to put left parentheses, and right away it tells you what variables you're going to include in this equation. It says Linest, known y's, known x, constant, and stats. I'll tell you what the constants and stats is, but known y's are these right here. The known x are these right here. So what I'm going to do is after I put left parentheses, I'm just going to move my cursor and highlight my known y's. Okay, and then release, and that's what's on Linest. D3, this is D3 down to D9. Then I'm going to put a comma, and then I'm going to put my known x. B3 through B9, I could also just type it in, but it's easier to just highlight it. And then I'm going to put comma, true, no space, comma, true. The variables that I want for constant and stats are true, comma, true. Don't worry what that means. It's just a condition. Once that happens, you do a right parentheses. Don't hit return yet. This is the most important part. If you hit return, you mess things up. Then you hit your shift, press your shift, and your control key. Okay, before you hit return, you need to hit shift and control, and then return. If you forget to do that, look what happens. If I just hit return, nothing occurs. I only get the slope. Okay, that is an error. What I need to do is I need to go over here, highlight my 2x3, hit shift control return. Now it puts in all the values that I'm looking for. Notice that from my original curve here, that the correlation factor, just doing a linear regression, was 0.9983. Well, here it's much more accurate. It's 0.99925. This is a better way of getting it. Notice that my intercept is 852. Here it's 869.13. And the reason why this is off is probably because this equation right here, I force it to go through 0 this equation right here, it's not forced through 0. It's actually based on the data. So let me go back here and change this. I want to change this so that it doesn't go through 0. I'm going to do this again. And just do this. Add trend line. And then I'm not going to click on this set intercept. I'm just going to do this and that. Now you can see that these values right here are much better. It is correlated to what I just did in Linest. And that's what you do for that first problem. If you take a look at the first problem, what you need to do next is size up your table. Make sure everything's on your spreadsheet. And then if you do Shift Command 4, then you can just highlight this area like that. And then when you do the screenshot, let me show you what the screenshot looks like. You can paste it into your activity. Here's the screenshot. Okay, let me pull this out. So this is a screenshot, and you guys are going to do a bunch of screenshot because that's the way you show your work. So I can just take that screenshot, and then in my activity, that's basically what I'm going to do right here. Choose a file, and that's what I'm going to upload. So this M, S sub B, S sub M, S sub B, R squared, and S sub Y, that's just these values right here. Okay, but you have to, the important lesson here is to make sure you know how to use Linest in Excel. That's why I'm not afraid to show you the answer, because I really want you guys to learn how to work the program. You need to know how to work the program, because if you don't work the program, then when you're asked to do so for some of the data, and you guys will be using Linest a lot for the data for this experiment, you won't know how to do it. Of course, there are tutorials. I give some tutorials on how to do this. Okay, I think if you go to the module page and you look at the this part right here, getting to know Excel, that's just a word. I think if you go to the Google Docs, probably. Okay, let's go to Google Docs. I think I put in tutorials in there on how to do Linest. So let me just show you where that is real quick. That would be under syllabus. Or is it under home? Should be, where is it? I don't see the link for the Google Drive. Okay, it should be here. If you don't find it, then it should be in this announcement page. I don't know why it's not there, but the Google Drive will have that. Let me just do that from here. This is the Google Drive link. Make sure you bookmark it. That's probably the best way to do this. Under Google Drive, you should also see labs. And under labs, you should also see, by the way, you guys are going to be using Vernier a lot. So download the Vernier software in your computer, because you guys will be using Vernier a lot. So if you just click here, it's called Logger Pro. You can download it. Okay, so that's going to be in your Google Drive for the class. Let's go to labs. Let's go to activities. And if you go to the activities, experiment number 3. Yeah, I don't see it. I will upload it here so that you guys can see the tutorial on how to do Linus. Okay, but you'll also be able to see how to do Linus once I upload the Zoom session for today. Let me move ahead because I do want to go through a couple of things today, and then we will be done. Okay, let's go to activity 3. The next thing I want to do, so this is completed. We just completed that. Is this question right here? This is a dimensional analysis problem. This is a concentration problem. Okay, let me give you some hints on this problem. First of all, you need to know the molar mass of this chemical. It's got 1 iron, which is about 55. Iron has a molar mass of 55.845. Okay, it's got ammonium. Ammonia, NH3 is 17. Ammonium, NH4 is 18. And there's 2 of them. It's got a sulfate, SO4. A sulfate is 96, and there's 2 of them. And this right here is 2 waters. So if you do the molar mass of this, it comes out approximately about 320. Okay. And this question is, what mass of this compound is required to prepare 500 milliliters containing 100 parts per million of iron? So you need to weigh a certain amount of this compound so that when you prepare 500 mils, it has in it 100 parts per million iron. Okay. So the way you do that, I'm not going to do that problem for you, but I will help you set it up. You need to know the molar mass of this chemical. And like I said, it's about 320. Get a better value. So the molar mass for this chemical is about 320 plus or minus. The molar mass of iron is going to be about 55.85. Okay, and then it tells you the information is you have 500 milliliters or 0.5 liters. That's 500 milliliters. That's what the problem gives you right here. And then you have 100 parts per million. And you want 100 parts per million iron. Now, this is a really handy piece of information that I'm going to tell you. 1 ppm is actually equal to 1 milligram of substance in 1 liter. Okay, that's a mass volume. If you've got glucose and you want 1 ppm, weigh out 1 milligram of glucose. It doesn't matter what the molar mass is because this is mass per volume. Weigh out 1 milligram and dissolve it in 1 liter. 1 ppm is 1 milligram in 1 liter. So 100 ppm is 100 milligrams. This is actually 100 milligrams in 1 liter. That's 100 ppm, 100 milligrams of iron. So the way you set up this problem is, again, I want you guys to see what's going on. You're going to prepare 100 ppm solution of iron, but your iron comes from this source, So you need to know the molar mass of this and the atomic mass of iron, because you're going to take the 100 ppm of iron. Let me draw you the flow chart. You're going to take the 100 ppm of iron and you guys are going to convert that to 100 milligrams per liter of iron. Then from the volume, 0.5 liters, you guys are going to use the volume to get just milligrams of iron. Okay, so at this point, what you should get is, when you do this dimensional analysis, 100 milligrams iron per liter of iron times 0.5 liters, what you have is milligrams of iron. That's your result. Then from the milligrams of iron, you want to use the molar mass, the atomic weight, and the molar mass so that you can get the mass of the compound. Again, let me stress. The first part, you'll get the mass of the iron. But you can see from this formula that if you have 1 mole of iron, you also have 1 mole of that compound. So that's why you need the atomic weight of iron. What you want to do now is take that milligrams of iron, convert it to grams, and take that grams of iron, convert it to moles. And then you can use the molar mass of this guy, because for every 1 mole of this, you also have 1 mole of iron. You use the molar mass of this compound to get the grams of that compound, and that's how much mass of compound you need. So you can do this all via, guess what, dimensional analysis. If you just set it up, you will see how the units cancel out. So that's all I want to say for that. I think I've given you the steps. Go from 100 milligrams per liter, convert the 100 milligrams to liter and get rid of the liter. Now you have 100 milligrams of iron, convert 100 milligrams of iron to grams of iron, convert grams of iron to moles of iron, convert moles of iron to moles of iron ammonium sulfate, and then you can use the molar mass of iron ammonium sulfate to get the grams of sulfate. That's the sequence that you would use via dimensional analysis. Okay, so that right there is, again, concentration conversion. You need to know how to do concentration conversion. I'm going to do this part for you, and then you guys can do Linest for this, okay, and then solve the rest. You do another Linest for the result, and then the last problem right here, it's a tough problem. I'll let you guys think about that, have it percolate in your head, and then we'll touch on it next Wednesday. But let me do this problem for you, and then we'll call it a day. Okay, we've now completed this. Show your work. Let's look at this. For this problem right here, what you have is let's read the problem. You're going to prepare a series of dilute solutions. So whenever you have a dilution problem, guess what? You do C1 V1 equals C2 V2. So that's the equation that we want. We want C1 times V1 equals C2 times V2. The problem really is to identify which is C1, which is V1, which is C2, which is V2. So let's figure this out. So let's take a look at this problem. Using the stock solution from 2A. So the stock solution is 100 ppm. Stock solution is always your original solution. Right away, that is C1. Okay, so your C1 is 100 ppm iron. Using the stock solution from 2A, what aliquot? So you're actually trying to calculate V1. It says right here, what aliquot? What portion do you need to prepare? To prepare means that you're going to make a second solution. That's your two, C2 and V2. 100 milliliters, that would be your V2. With these concentrations. So these would be the various concentrations for your 1 to 5 solutions. Okay, so what aliquot of the stock do you need to prepare that? And you're putting it in a 100 ml volumetric flask. So all you're doing is using C1 V1 equals C2 V2. I've already told you what C1 is. I've already showed you what V2 is. It's going to be 100 milliliters for all of these. And your C2 are going to be these different values. And it's going to contain this amount of iron in these 5 solutions. Okay, so you guys can do that. You're just using C1 V1 equals C2 V2. And then once you complete that, this right here is just another graphing. Plot this and get Linest. And then what you will see is that one of these points are off. You need to delete it. And you need to get your correlation factor to be a better value. Because right now, the data for this is not very good. You got to delete one of the points. It's not necessarily the end, but just practice, delete one of the points, see whether or not you can improve your correlation factor, and then regraph it with just not 5, but with 4 data points. Okay, and then do Linest again. Do a screenshot because you guys are going to upload the file. And then your very last problem is a tough one. What you need to do is you need to use this graph that you generate here for this problem. Okay, the graph that you generate is like a calibration curve. So from the calibration curve, you're going to look for the iron that has 0.335%, and you're going to calculate information from that graph. Yeah. So you guys should have gone ahead and plotted this and gotten the Linest. There was some question about how to do Linest. Again, let me show you how that works. And then I'll show you my steps in my keyboard. But for now, let me blow this up so that you guys can see. Okay, let me clear this so that you guys can see. This is the plot that I have, and I highlighted the X and the Y values here. Let me also clean this up so that you guys will be able to. So I'm going to start from the beginning in terms of this. So this is the data from here. That's your CH4 volume percent. This is the signal. This is the uncorrected signal. And this is the corrected signal. The corrected signal is based on taking your signal and subtracting. So right here, they're subtracting the baseline 9.1, which is the residual signal when no CH4 is present. So you have to subtract 9.1 from each one of these readings, and that would be the corrected signal. So 9.1 minus 9.1 is 0. 47.5 minus 9.1 is 38.4. 95.6 minus 9.1 is 86.4. Now, you can do this by hand, but it's easier to just write a formula. And the formula is going to be taking this cell, subtracting it from this cell, which happens to be C3. This is like battleship. This is a grid. This is C, and this is 3. This is C, and this is 4. So by putting a $sign before and after the C, you tell the equation that that particular cell is not going to deviate when you do a progression of calculation. Okay, that's key. So that's what you need to include in this formula. This is C3 minus C3, but now this $C, $3 tells you that I'm not going to deviate from that particular point in my calculation. Erase that. And then what I want to do is highlight that cell, grab that square right there and then drag it down. That'll be the progression of calculations. Next, I want to do a trend line. And the way I do a trend line is, or I plot this by highlighting this, clicking on options, oops, clicking on this, and then command. You're going to hit one of either command option in your keyboard if you have a PC. For Mac, it's the command key. The command key looks like this. For those of you who don't know what a command key looks like. So this is my keyboard. And if I zoom into my keyboard, okay, then you will see that the command key is right here next to the keyboard, to the space bar. That's my command key. And then so again, let me show you how that operates. I highlight my Y value, hit my command key, and then I highlight my X value. And now both of those columns are highlighted. And then I can just go in here and do a insert a chart. And I'm going to do a scattered, okay? And it's going to be XY scattered. And that's what you see right here. This is an XY scattered, okay? So that's basically it. The next thing I want to do is I just want to delete this. You're going to have to clean up your chart, put a good title, make sure that you have the units properly on the axis, okay? But just click on that and then right click. If you have a mouse, right click. And when you right click, you get the contextual menu that you see on the screen right there. Or you can just do, I believe it's option. No, it's control click. Control click and right click are the same thing. You get this contextual menu. I want to add a trend line. Okay. And when I add a trend line, I have that, and then I get this display. I'm not going to set it to the intercept to the 0, but I do want to see the equation and I do want to see a correlation factor. I'm just going to close this out right here, and now I have that. Okay, so that's basically the graph for this data using the corrected and the CH4. Next thing I'm going to do is I'm going to do Linest. And the way I do Linest is I'm going to need to highlight a 2x3 grid. That's what you see right here. I highlight that. Again, I'm just clicking, highlighting this, and then releasing it. And then I'm going to the formula bar. This should still be highlighted, but I'm going to the formula bar, and then I'm typing in equals Linest. Linest, left parentheses. And if you look at real closely, it actually tells you known y's, and these are my known y's, and then comma, known x, it's this right here. I'm going to highlight that, comma, true, comma, true. Okay, the two constants at the end is just true and true. And then I'm going to do a left parentheses, but I'm not going to hit a return yet. Okay, I want to make sure that this 2x3 grid is highlighted. I'm going to put my mouse on that equation, and then I'm going to do shift control. Look what I'm pressing, shift control, and then return at the same time. That's what I'm pressing, shift control, return. And when I do that, then that cell, this pops up. If I do not do that, then it's going to give me an error. So the key is to press, let me do that again. Okay, you should have in your equation bar equals Linest, known y's, comma, known x, comma, true, comma, true. So both are true. I got to spell true correctly. Okay, left parentheses, and then shift control. I believe that's the same command as a PC, and then return. Don't just hit shift control, release, and return. It has to be shift control, keep it down, and then return. And you got to make sure that the 2x3 grid is highlighted, and that'll give you your data. Okay, so what you have is you have a slope of 869.13. That correlates very well to this graph. You have an intercept of minus 22.085. That correlates very well to this graph. And you have a correlation factor of 0.99925. That correlates very well with this graph. Of course, this is rounding off to 4 significant figures, and this goes to as many as you want. So that's how you do Linest. Okay, that's how you do Linest for this. So if you do this activity correctly, you would have gone through here, you would have answered this, okay, and then you would have gone through 2 graphs, and your 2 graphs would look almost like this. Okay, you have a first graph, and you notice that, let me just blow this up so that you guys can see. This is a first graph, and if you do the first graph, you see that the correlation factor is only 1.9. Okay, it's only got 1.9. So you have to decide, which data point do I eliminate? Do I eliminate this data point, or eliminate this data point, or something else? And you can easily do that by just taking this and deleting it. Okay. So again, if you click on any one of these points right here, it'll highlight your table, and it'll highlight the points that make those. It'll highlight the data that makes those points. So what I'm going to do is I'm going to remove this one and look at the correlation factor. So you can do this in real time. I'm just going to delete this. Okay. And I'm going to move the, I'm just going to remove the entire row. And look what happens to the correlation factor. Okay, that has 4 9s when I remove that last point. Let me do a Control Z, which is undone. Okay, Control Z. I think a PC will also have the same command. And let me remove data number 4, this one right here. And I'm just going to delete that. I'm going to move the cell up. And you can see that by removing data set 4, that only gives me 0.98. So that's the wrong one to remove. I'm going to do Control Z again, gives me the original. Now I know that I'm going to need to remove this last data point. And when I do that, I get a better set of data. Okay, that's how you would fix that. Okay, if you're getting zeros for all those values, the question I have is, what version of Excel are you using? Are you using Microsoft 365, or are you using Microsoft something? Okay, so if you can answer me, because I think I know what the problem is. Is Sierra? Yeah, you're using Microsoft 360. Unfortunately, that version, I apologize, does not have the Linest function. I know because when we meet in class, this was prior to the COVID, and students were using that. I was scratching my head all over as to why it wasn't working. And then I realized that Microsoft or Office 360 does not allow you to do that. Don't worry about it for now. For those of you who are using Microsoft 360, they shortchange you, okay, in terms of that program. That program is limited in terms of its Excel function, its Excel capability, as well as its PowerPoint capabilities. I don't know what limitation it has in Word, but I know that in Excel, it doesn't allow Linest. So let me do some research on that. Yeah, you can do Google Sheet if you want, but let me do research on that and then get back to you. If anything, if you can't do the Linest, just put in your paper that you're using Microsoft 360, and then just get me this correlation factor, and then I'll figure out how you guys can do Linest, because the reason why I want to do Linest is because I actually want to see the standard deviation of your slope and your intercept. Those are the main things that I want. And you don't get that when you just do a add trend line. Okay. You don't do that when you just add trend line. The reason why I want to see a standard deviation of your slope and your intercept is because it tells me how far off you are. Remember that the slope tells you your rate constant in most of these things. So it tells me the error in your rate constant. That's why I want to see the standard deviation of your slope. But don't worry about it for now. I'm going to have to do some research and see why Microsoft 360 does not allow you to do Linest. I apologize for that. I should have remembered that from previous meetings, that you guys don't have the Linest function in Microsoft 360. Okay. Yeah, I feel bad. Anyway, let's move on, because this is what you guys will be doing for this part right here. See this part right here, 2.2c. This is the original data, and then this is the data, the Linest. And if you can't do Linest, then you're just gonna have to skip S sub M and S sub B. But you can get the correlation factor, but not the standard deviation. And this would be the second part when you throw out the bad data point. Okay, when you get the second data point, okay, when you get the second data point, you're going to use this graph for the last problem. Let's take a look at the last problem. It says right here, using the calibration curve determined in 2C, that's this one that's corrected right here, okay? It says, if a blood contains 0.335% iron. So let me write this down so that you guys can see what I have here. Let me change my screen here. Okay. Let's see. I gotta get better lights here. I think you can see that. There's too much glare though. Okay. Okay. So what I want to show you is how you would work this particular problem via dimensional analysis. First of all, write down the data. You've got 0.335% iron in blood. Okay, so it's 0.335%. What does that mean? It means that you have 0.335 grams of iron in 100 grams of blood. That's what you guys have got to learn about some of these things, is that this 0.335%, you've got to expand it to both the solute and the solution. And that 0.335% means 0.335 grams iron in 100 grams of blood, because 0.335 divided by 100 times 100 is 0.335%. So that's the first thing that you have. Then you know that you're going to dilute it so that you have a solution. And you want to use a volumetric flask. So the solution is 250 milliliters. Okay. So you want to take a blood, say it's in a test tube, and you need to know that volume. In fact, that's what the question is. You're going to put that blood into the volumetric flask. You're going to fill it with, probably water. That's my water bottle. Okay, you're going to fill it with water so that the total volume is 250. Okay, this solution has a density of 1.0 grams solution in 1 cc solution. Tells you right there in the problem that the solution has 1 gram per cc, but the blood is 1.070 grams of iron in 1 cc of blood. Okay, that's the density of the blood. So the question is, in this particular problem, is what volume, that's my question, what volume of blood do I need so that when I prepare the solution and I put it in a cuvette, okay, when I put it in a cuvette, that cuvette has an absorbance of 0.250. That's the question. Okay, so let me show you how. And then this volume that you guys are calculating, that volume is in milliliters and microliters. That's what you want. So let me show you what you need to do. First of all, you don't start here. You don't start with that. You actually start at the end of the problem. You need to find the absorbance at 0.2500, okay? What iron concentration is going to give you an absorbance of 0.250? Well, what data do you need? Well, you use this data right here, this graph. So what you need to do is you need to find the absorbance, that's your y-axis here, and then you need to extrapolate to this correlation line and figure out the concentration of iron, because the concentration of iron is along the x-axis, the absorbance along the y-axis. But you already have the equation of the line. The equation of the line is right here. Okay, the equation of the line right here. This is your intercept right here, 0.0309, and this is your slope. So what you want to do is you want to say y equals mx plus b, but your slope is 0.113307 and your intercept is 0.003093. Okay, not using all the digits that I have. I need this to be 0.250 because that's going to be my absorbance. This is my absorbance. I need to figure out what concentration of iron do I need. So if you have this equation, y equals mx plus b, and you have the slope, you have the intercept, and you know what absorbance you want, then you can calculate what concentration of iron you need. Okay, that's basically what that is. That's what, and this, according to your graph, is going to be in parts per million. That'll be parts per million. So the way you finish this up is you start with that. Let's say that this particular, let me just eyeball this. Let's say that the concentration of iron based on the graph, I'm just going to make it up, is 2.00 parts per million. Okay, I know it's not 2 because if you look at this right here, you can see that 2 is right here. Maybe it is 2. Okay, based on the correction, it's actually greater than 2 because this is 0.25. So let's just say, for the sake of calculation, it's 2 parts per million. And let's take a look at this data right here. Okay, just look at this. Okay, so what is a parts per million? A parts per million is, maybe I didn't tell you this, but let me tell you now. A ppm is a milligrams per liter. If you have 1 parts per million, then that's 1 milligram per 1 liter. Okay, so we can take this 2.00 ppm and say it's 2.00 milligrams of iron in 1 liter solution. Okay, now we do dimensional analysis. This is liters of solution. What volume are we going to prepare? Right there, 250 milliliters. But 250 milliliters is 0.250 liters. Okay, so that's where you put that. You put the volume in liters here. That will cancel out the volume of the solution. Next thing you want to do is, you know that your solution has to have 2 milligrams of iron per liter solution, but your blood is 0.335%, according to your data, 0.335 grams per 100 grams of blood. Well, this is milligrams of iron. So you need to convert milligrams of iron to grams of iron. It takes 1,000 milligrams to equal 1 gram. Okay, the milligrams will cancel. Then we can use this conversion factor 0.335 grams of iron in 100 grams of blood. That's where 0.335% comes into play. Now the grams of iron will cancel, the milligrams will cancel, and now you have, when everything cancels, your answer here will be grams of blood. Okay, how do you convert grams of blood to milliliters of blood? Well, you have one more conversion factor, and I'm not going to do that step for you, but you guys can do it via dimensional analysis. Look at the density of your blood. It's 1.070 grams per cc. So 1.070 grams per 1 cc. And that's how you convert grams of blood, in this particular case, to cc's of blood, and a cc is a milliliter. Again, dimensional analysis. If you don't know how to do dimensional analysis, please go back and learn how to do that, because it'll always bail you out. Like in this problem. This problem, I didn't use any formula. I just let the units walk me through. And if you do this correctly, your volume in milliliters will be about 0.15, 0.16, somewhere around there, okay? In milliliters. In microliters, it'll be like 150, 160, 140 microliters. But that's
excuse me, Professor?
Yes.
We can't see your paper very well. It's pretty
Oh.
blurry. And yeah, I haven't been able to really get any information from the paper. And it's also showing in your character screen, so we can't really see it that well.
Yeah, well, you sort of, let me go ahead and take a picture and then upload this, okay? So you guys can see these 2 pages that I have. But yeah, hopefully you'd follow along in terms of the words that I do have. Yeah, I know this camera that I have right here is not very clear, but it gives you an idea of the calculation. So I'll take a picture and upload that, okay?
Thank you.
So so let me go ahead and that should get you to that last problem. But that last problem is really a good, clever problem that shows how absorbance data is used in chemistry to prepare a solution that you need. Okay, so I'll go ahead and do that. And then what I can do as well is that when I do edit the video, I can actually do a split screen and hopefully maybe blow this up so that it'll show better. So
no, well, we're able to actually click on your face. It's just the quality of it is just very blurry.
yeah, I know the quality is bad. So if I blow it up, yeah. Well, like I said, I'll take a picture and you guys can follow it. Okay. So hopefully that'll make things better. But if you get a number, like I said, between 140, 160 microliters, then you're in the right ballpark.